Welcome everyone. So glad you're here. Today, we're diving straight into a seriously fascinating framework from the team over at Codata. We're going to unpack their building block approach to data architecture. Specifically, we're looking at this concept they call atomic integrity. If you've ever found yourself wondering how we can actually tangibly build reliable, completely verifiable data systems for AI, well, you're in the exact right place. In this explainer, we're going to break down exactly how raw work literally transforms into verifiable data assets.
Okay, let's dive right into this with a pretty massive paradigm shift from our source material. Listen to this. The structure of data tells you everything about how much it can be trusted. I absolutely love that. We so often talk about trusting AI as if it's, just a promise or some abstract feeling, but Codata is arguing something entirely different here. They're saying trust is a physical architectural reality. It's literally an engineering output. Think of it like a building. If the structure of your data is flawed, the trust is broken. But if the foundation is sound, trust is basically guaranteed.
So, moving right along to Section 1, trust resides in structure, building accountability from the ground up.
Which brings us to Section 2, the atomic contribution. Now we're zooming way in to the micro level.
So the crucial point is, according to Codata, absolutely everything starts at this microscopic level, the atomic contribution. We define this as the absolute smallest unit of data. Imagine, say, just a single sample of information, or maybe one specific label applied to a single image, or even just one individual validation of a fact, right? By stripping data all the way down to this core bedrock, and defining this tiny building block so precisely, we can start to see how an incredibly complex AI dataset isn't just magic. It's really just a massive collection of these individual atomic actions.
But here's the thing. An atomic contribution on its own, it's just not enough. It desperately needs accountability. So every single one of these microscopic units carries what's called a contribution fingerprint. And this is huge. It records exactly who performed the action, exactly when it happened, and exactly what payload it touched. Just think about the momentum this creates in a system. By adding this ultra-specific fingerprint to every single sample or label, you're creating this immediate, unbreakable cause and effect accountability. There's no more mystery data. None. Every single piece of information has a distinct, perfectly verifiable origin story.
All right, let's move to Section 3, the complete data asset, and see how this builds by snapping the pieces together.
And here we have the data asset. This is the actual unit that AI teams work with in the real world. I want you to visually imagine all of those tiny, completely accountable micro-units we were just talking about literally snapping together, like Lego bricks, to form a larger package. These individual atomic contributions, each carrying its own totally unique fingerprint, aggregate perfectly. They build the exact structures that AI developers need to train their massive models.
And this brilliantly illustrates the whole Codata architecture. The content and the labels that actually give it meaning arrive as a single, unified package. Compare that to the old alternative, right? Having separate files that, let's be honest, inevitably lose connection to each other over time. When you have disconnected files, you lose the context, you lose that crucial fingerprint we talked about, and ultimately, you lose the trust. Keeping the content and its labels structurally bound together as one single data asset, well, that's the ultimate solution to the absolute chaos of disconnected data.
Now, because that content arrives in a tightly structured, fingerprinted package, we get to the ultimate payoff. A data asset explicitly carries ownership, licensing rules, and royalties. We aren't just talking about abstract legal concepts floating around in some external contract somewhere. No, they are explicitly carried by the data asset itself. Because we started with that accountable atomic contribution and snapped those together into a unified package, these highly specific economic rights survive perfectly intact, all the way from the creator directly into the AI developer's hands. It's a real game changer.
Moving out to the big picture now. Section 4, verifiable and economically aligned, looking at the macro ecosystem impact.
Now what's really interesting about this slide is that when we look at the complete journey, every single step, from that very first atomic contribution all the way up to the massive finished dataset is clear. It's verifiable, and crucially, it is economically aligned with the actual people who built it. This architecture doesn't just guarantee a technically sound dataset, though it does do that. It guarantees a truly fair system from start to finish. The folks doing the raw work are economically connected to the final product, simply because the very structure of the data demands it.
Which leaves us with this final, absolutely vital question to ponder. If raw work is now a fully accountable building block, how will economic alignment change the way we actually build AI? Think about it. If every label, every sample, every validation explicitly carries its own history and its own economic rights, the whole future of AI development looks entirely different, doesn't it? It becomes a system built on real, verifiable trust and completely transparent value. I really hope this explainer has given you a completely new perspective on data architecture and, the profound importance of structure. Take this question with you today and keep exploring.